Okay, guys, so this is the third problem of the exam. We need to calculate the following limits, okay? So let's start with the A one, okay? So here we have that the limit when x goes to infinite of this function, okay? The inverse of sine. So you can introduce the limit over over the x, right? Next to the x, you can introduce it. So we do it this way, okay? So now we need to stop one moment and try to analyze what we are doing, right? We need to calculate the limit when x goes to infinite. Here I have a capture of the function sine to the minus 1, right? The inverse of the sine. So if we want to analyze to understand what happens beyond infinite, if we go over here, the function is not defined, right? So we have a problem here, okay? So you have like two paths here. First of all, you can apply L'Hopital, right? Why L'Hopital? You apply L'Hopital when you have infinite over infinite or 0 over 0. If you plug, right, this x over here and over here, what you're gonna have is infinite over infinite, right? And you and then you have to derive the function, okay, to obtain the derivative. But you can do also this trick, right? We can say this. We can say, you know that if we're plugging infinite here, then we're gonna have that infinite, let me do it here, infinite to the square is gonna be way bigger than 3x and also 5. Exactly the same with the denominator. 2 multiplied by infinite to the square is gonna be way bigger than 7x. I mean 7 multiplied by infinite, right? So at the end, you're gonna have this one. You're gonna have sine minus 1, right? And the limit when x goes to infinite of what? You're gonna have to take always this one and this one. You need to take the biggest power of the x in the numerator and the denominator. So in this case, you're gonna have easily, what you're gonna have? You're gonna have x squared divided by 2x squared. And then you can simply cancel them. And you're gonna have, right? You're gonna have sine, the inverse sine of 1/2. Okay? And here is the, okay, so this one like the first method, right? And the second method is the one that I explained you here, right? So at the end, you want to take just the biggest power of the numerator and the denominator, and that's it. You got it. So the inverse sine of 1 over 2, right? We need to analyze it, right? Here you need a result that is gonna be in radians, pi over something, right? So in which value of radians you have 1/2? Basically in pi over 6. If you go to the calculator, right, and you say inverse sine of 1 over 2, this is well, in my calculator it shows 30 degrees, right? But you always have to express your answer in radians. So this is gonna be pi over 6, right? And pi over 6, right? Pi over 6 basically is 0.52, right? So I don't know if you can see it. Let me do it here more bigger, so you can see it, right? Because in limits you need to understand what's happening, right? Okay, so pi over 6, if you go to your calculator, you're gonna have 0.52. So this one basically it's like over here, right? And you have the 0.5. So this is the point that you want, right? So you already find that pi over 6 satisfies this equation of sine evaluated in 1/2. Okay.